Hi chemistry students, I hope you're doing well. I am going to be going over lesson 27 today. It's kind of complex, but it's just a lot of steps, but I believe that you'll be able to do it. Basically, this chapter is about molarity and stoichiometry, which means you're going to be combining everything that you've learned about moles and grams, and solutions, molarity. This chapter basically goes over if you have so much reactant, how much product are you going to get? And they're going to give you milliliters of a solution of a certain molarity, and then you will figure out how much product you're going to yield in that reaction. So it's a lot of steps, but it just combines everything that we've already learned. So I'm gonna go over it step by step with you, and we're gonna do two practice kind of problems, and we'll see what you think, okay? So first, let's kind of review. We're gonna talk about molarity. Remember, when you're talking about the molarity, you're dealing with a solution, and it means that there's one, if you have a solution that's of a molarity of 1, it means you've got 1 mole per 1,000 milliliters or 1 whole liter, okay? If you have a 2 molar solution, or then it'll be 2 moles per 1,000 milliliters. If you have a 0.5 molarity solution, it's gonna be 0.5 moles per liter or 1,000 milliliters, okay? So that is important to understand. We're gonna go over your page, let's see, your page 256. We're gonna look at one of the sample problems and go over it together. I feel like that's the best way, is to look at an example and go through it step by step so that you understand the process of figuring out how to work these equations, okay? Don't get scared, it's just a lot of steps, okay? But we'll do it together. So your page 256, we're going to look at example number 1, and it says when sodium hydroxide is mixed with hydrogen chloride, sodium chloride and water result. Suppose you have been given 100 milliliters of a 5 molar solution of sodium hydroxide. How many grams of sodium chloride would you yield from this reaction? So the first step, we write our chemical equation. So we've got sodium hydroxide plus hydrogen chloride, and that yields sodium chloride and water, okay? It looks like we're totally balanced, okay? So we're just gonna keep it as is, okay? That's step 2, balance the reaction. Step 3, locate the reaction components that we're interested in, and we'll box them. So we know, this is our known, our sodium hydroxide, and we need to know how much sodium chloride we're gonna get in this reaction, given whatever amount we have for this, okay? So this is just an extra step of figuring out how many grams or moles of this we have that will make so much of this, okay? It's pretty much what we've been doing, only we're adding another step of the whole molarity component, okay? So next part, we've got 3 steps. You make the chemical equation, you balance the reaction, and then you locate the reaction components that we're gonna figure out, and then we're gonna determine the mole ratio, and the mole ratio is 1 to 1. So that makes it really nice and simple. Okay, so for every 1 mole of sodium hydroxide we will produce 1 mole of sodium chloride. So the next part that we need to do is figure out how much sodium hydroxide we're starting with. So what we know about the sodium hydroxide is we have 100 milliliters of a 5 molar solution. Okay? So let's figure out how many grams of sodium hydroxide we started with. Okay? So our first step is figuring out this solution. We've got 5 moles in 1,000 milliliters, right? That's the molarity of this sodium hydroxide, okay? And what we need to figure out is how many grams we're starting with. So we're starting with how many moles of this solution, okay? So we started with 100 milliliters. How many moles are we starting with here? So you cross multiply these, okay? That's 1000x equals 500. We're gonna divide both sides by 1,000, and that equals 1/2. So we started with a 1/2 mole, okay? I actually went ahead in I'm solving this a little bit differently actually. But I figured out we have a 1/2 mole that we started with of NaOH, okay? So if we started with if our mole ratio is we have a 1/2 of a mole of NaOH, we're gonna have a 1/2 of a mole yielded in this equation. This sodium chloride is going to be, we're gonna have a 1/2 mole of it, okay? So, because the mole ratio is 1:1, right? So we know we've got 0.5 moles of sodium chloride. So then how do we figure out how many grams we have? Well, that's pretty simple. We figure out the molecular weight of sodium chloride. So sodium chloride weighs 58 grams per mole. Okay, and we have 0.5 moles, so we're just gonna multiply it by 0.5. And so basically that's 29 grams of sodium chloride. That's our final answer. So yes, it's a lot of steps, but you understand already a lot of the steps. It's just adding extra steps onto it with the molarity, figuring out how many moles or grams of whatever substance you've started with, and then taking that to the product side, okay? So that was the example number 1. They do it a little differently. They figure out the grams first instead of figuring out the moles first. But it ultimately ends up with the same answer, whatever works best for you. That way worked better for me. So what I wanted to do was do a practice problem and pick a difficult one with you guys. Let's see. We'll do number 2 on your page 261, practice problem number 2, okay? How much time do I have left?
You have 9 minutes for that.
Oh, okay, good. Okay, so number 2, it says Tony knew that ammonia or NH3 will react with hydrogen sulfide to produce ammonium sulfide. Okay, so first step, write out our equation. So they were saying that ammonia is NH3. And then it reacts with hydrogen sulfide. Sulfur is a -2, hydrogen's a +1, so that's how we write hydrogen sulfide. and that yields ammonium sulfide. And ammonium, if you remember, this polyatomic ion is NH4. It has a charge of +1, and sulfide is -2. So you need to do it that way, okay? And then I'm gonna balance this real quick. Instead of writing everything out, just to save a step, you just put a 2 in front of there to balance the equation. So step 1, write the equation. Step 2, balance. Step 3, we're gonna look at what's in question here. So we know we have 100 milliliters of a 0.5 molar ammonia solution. So okay, so we're looking at these and this, okay? And our mole ratio is 2 to 1, okay? So we know we started with 100 milliliters of a 0.5 molar solution of this, okay? So our first step is, let's figure out how much we've started with, okay? Let's figure out how many grams are in 100 milliliters of a 0.5 molar solution of ammonium, okay? That's how we're gonna figure out. We need to know how many grams we have of this to figure out how many grams we will end up with this. So what we'll do is we'll find the molecular weight, which of this, NH3, its weight is 17 grams, because that's 14 and 3 hydrogens is 3. Okay, and we know that there's half of a mole of ammonium in this solution, right? So if we know we have half of a mole, let's divide that by 2 real quick, and that's 8.5. We have 8.5 grams of NH3 in 1,000 milliliters of solution. That's the molarity, okay? So we know we have that much, but we only have 100 milliliters of the solution. So let's figure out how many grams we have in 100 milliliters. So you just use your ratio and proportion. This is our unknown. We don't know how many grams we have, but we do know that we have 100 milliliters. And how we solve this is you cross multiply and then divide. So 1,000x equals 8.5 times 100, and then x equals, we'll divide, so 8.5 times 100 equals, what does that equal? I didn't write it down, and I can't think. What is it?
850.
850. Thank you.
Well, 8.5 times 100 is 850.
So it's 885. Okay. And then we have to divide, we have to get x by itself.
8.5 times 100 is 850.
8.5? It is? Okay.
Times 100.
Okay. So it's 850, and then we're going to divide it by 1,000. And our answer is we have 0.85 grams. That's what we've started with. We started with 0.85 grams of ammonium. So how many moles is that? So if we have 0.85 grams, let's divide it by the molecular weight, which is 17 grams per mole. And that equals 0.05 moles. So we started with 0.05 moles of ammonium, okay? So let me erase this and just. We've got 0.05 moles of that. So what does that mean for this? How many moles do we have of this? We go back to our mole ratio, right? So we have 0.05 moles of NH3. Our mole ratio is 2 to 1. That means we have half as many of this as we do of that in moles, okay? So that means we have 0.025 moles, okay, of the ammonium sulfide. I hope that makes sense, because that's our mole ratio, 2 to 1. So that's what we have of this, but they want to know, we're not done, we have to know how many grams are produced from this reaction. So next step is, if we know we have 0.025 moles of ammonium sulfide, let's find the molecular weight and multiply it by how many moles we have. So the molecular weight is 68 grams, okay? So this ammonium sulfide weighs 68 grams per mole, and we multiply it 0.025 moles, because that's how much we have, and that's what it weighs per mole, and your answer is 1.7 grams of ammonium sulfide. Clear as mud, I hope. I hope that you guys can understand the steps I went through there. There's just so many steps. They do have a guide to follow on your page 260 that gives you step by step what you're supposed to do in each of one of these problems. First you write and balance the reaction, then you locate the reaction components, and then you determine the mole ratio. You got that. Then you find the problem, the amount and molarity of the ingredient that you're given. You convert the milliliters of the reactant into grams. You convert the grams into moles, and then you apply the mole ratio, and that's all you do. So tell me what you guys think. Let me know if you can handle this. Give me an email, and we'll take it from there. I'd like you guys to do your practice problems. I'll send you the solutions, and just try your best to do the test, and turn it in next Monday, okay? And that's all. So let me know if you have any questions. Text me, email me. You can even call me if you need to, okay? Take care. Bye.